This set of notes is on general writing and balancing equations and just a summary of balancing chemical equations. So the first thing that we're going to do when we are working with chemical equations is we're going to identify the name of each of the reactants and all of the products and then write the correct chemical formula. So we're going to apply what we learned in the chemical bonds unit, both with ionic and covalent bonds, and we're going to write the correct chemical formulas now. So just a reminder, for metals and nonmetals, we're going to cross over our charges to make those the subscript numbers. So for example, those ionic compounds, so if I had aluminum nitrate here, I have the Al plus 3, the NO3 minus 1. Just a reminder, we're going to cross over our charges to make our compound look like that. So it's really important that we make sure that we're writing our correct chemical formulas. For two nonmetals, we're going to write just what the words say, so those are going to be our covalent bonds. And just a reminder there, we're going to use our prefixes, for example, carbon dioxide. And then also something to remember is our Cliff-Braun elements, so those are our diatomic elements. And those elements are going to be just written right like that. And then also a few elements are just going to be written alone. So for example, we're going to have metals by themselves, so copper or iron. These guys don't need a Roman numeral because they're not attached to anything. So if we remember our oxidation numbers, the charge on these would be 0 because they're atoms by themselves. So then we're going to balance according to the law of conservation of mass. So a balance equation contains the same number of each kind of atom on each side of the equation. So we're going to balance the different types of atoms or polyatomic groups at the same time. And so the thing that we need to remember though is that once we make our chemical formulas, we do not touch the subscripts anymore. So remember when I kind of joke with you guys, no touchy, like do not touch those subscripts anymore. So right here, the aluminum nitrate, as soon as you make that, you don't touch the subscripts anymore. To make sure that you have equal amounts on both sides, we're actually going to use coefficients. So we're going to use the big numbers in front of the compound to make sure that we have the balanced equation and that we're following the law of conservation of mass. So the first thing you're going to do is balance atoms of elements that are combined and appear once on each side. And then you're going to balance polyatomic ions and balance those as single units. It's much easier to work with those as single units instead of balancing those atoms individually. And then third, you want to balance hydrogen and oxygen atoms, not in a polyatomic group, but only after all of the other elements have been balanced. And really, honestly, don't worry too much about these rules. We'll go through some example problems, and you guys will start getting the hang of just making sure everything is even on both sides to follow the law of conservation of mass. So then what we're going to do is make sure that the third step here is we're going to count all the atoms to be sure that the equation is balanced. And then we're going to make sure that our reactants, which are on the left-hand side, are equal to our products, which are on the right-hand side. So we just want to make sure we have equal amounts of all of those. And then on this page right here, we're going to use this grid a lot, and this is just a reference point for things that will be included and seen in a chemical equation. Alright, so now I want you to get out your balancing and naming introduction sheet, and you're going to take some notes on this. This does not need to be finished for Friday. We are going to work on it during class. So just take some notes on it, make sure you write down the example problems so you have those with you when you come to class, and then you'll work on the rest of it during class with help of your teacher. So a couple of reminders here. The first thing we want to do is balance the chemical equations, and we're going to balance those with the coefficient, which is just the big number in front of the compound. So always, always, always making sure that your equation is balanced. And then we're going to write the names and the compound underneath the equation. So don't forget our Cliff-Braun here. This is a good reminder to rewrite on this piece of paper. And these guys act as elements by themselves. So for example, if I have Cl2, that's chlorine gas, that's not chloride. If I have O2, that's oxygen gas, that's not oxide. Think about it this way, we don't breathe in oxide, we breathe in oxygen gas. So don't forget on your Cliff-Brauns that we treat those as elements by themselves. And then another important thing to remember is use oxidation numbers to help figure out the Roman numerals if you don't remember for when you're naming. So let's do some examples here. We're going to balance chemical equations. So on this first equation here, I have 1 sodium and 1 sodium, so I'm good there, and I have 2 chlorines and only 1 chlorine over here. So the way to fix that is I'm going to put a big number 2 coefficient in front of that sodium chloride. So before I move on, I've got to check all of my formula again. So I have 1 sodium, but now I have 2 sodiums. So the way to balance that is that I'm going to put another 2 in front of that sodium. Lastly, before I move on, I'm going to check one more time to make sure that these are correct. So I have 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines. Everything is balanced. Once you check that everything's balanced, we're going to write the names of the compounds or elements underneath. So here I have sodium plus chlorine gas, and that's going to yield sodium chloride. So we're applying what we learned from the last unit in terms of naming chemical formulas to writing out whole chemical equations here. Alright, let's do another one example here. We're going to work on number 7. So if I've got 3 magnesiums, I'm going to look here, so I've got magnesium here, and I see I have 3 magnesiums here. That's why I added that 3 coefficient right there. So I'm good there. So now I have 3 hydrogens here and 2 hydrogens here. So I'm going to wait on that for a second because it's actually easier to balance our polyatomics first. So let's look, I've got a phosphate there, I've got 1 phosphate there, and I have 2 phosphates here. So this is what we're talking about in our rules, where you're going to balance the polyatomics together. So here I'm going to say, okay, well I need to put a 2 right here to make sure that I have 2 phosphates. So now I've got 3 magnesiums, 2 phosphates, 2 phosphates, and here now I have 2 times 3, so I have 6 hydrogens. Here I only have 2 hydrogens, so to make sure that that's balanced, I'm going to put a 3 right there. So then when I check one more time, it looks like everything is balanced, and so now I can name it. So I've got magnesium by itself, and then this is phosphoric acid, which is one of the reasons why I did this as an example for you. You don't ever need to know the names of the acids, and I'm going to actually give them to you at the end of this assignment, so you can write them down. Then we've got magnesium phosphate plus hydrogen gas is how you would name that. So there's your examples for the front side. Now turn your paper over and I'm going to give you some examples for the back side. So here's some reminders of what you need to do. So if elements are alone, the charge on the element is 0, so remembering from your oxidation numbers. So if I'm writing the charges above the words, which is always something that we're going to be working on, my charge for copper metal by itself would be 0, and the element of copper would be right there. And notice on like the metals here, I didn't include any Roman numerals because there is no charge, because it's a metal by itself. Chlorine gas, for example, it's considered an element by itself, even though it's diatomic, and so that's why there's a 0 charge above that. So the first thing that we want to do is we want to write the charges above the words, and then we want to cross over, make sure it's balanced, and then we'll check and make sure everything's balanced at the end. So we're going to do number 1 together. So iron, because it's a metal by itself, has a 0 charge. And also, just a reminder, if you have a covalent bond when you're naming, and it's monos, dis, and tris, you don't need to put the charges above the words. So, sorry about that, I forgot about that. So just, if you've got a covalent bond, you don't need to put the charges above the words. So now if I've got iron, it's a metal by itself, so it's a 0 charge. Sulfur, atom by itself, also a 0 charge. Iron 3 is telling me it's a +3 charge. Sulfide is a -2 charge. So now when I write my chemical formula, it would look something like that. So here I'm just crossing over the charges like we worked on in the last unit. And then before I leave, I've just got to make sure that I balance my equation. So I would need to add a 2 in front of the iron to make sure. So here I have 2 irons, 2 irons. I only have 1 sulfur here and I have 3 sulfurs here. So to fix that, I would put a 3 right there. Alright, so then our next example here, we're going to do number 6. So aluminum is a 0 charge because it's a metal by itself. Oxygen gas is a diatomic molecule, so it's considered an atom by itself. So we leave it as a 0 charge. And then we've got our +3 -2 aluminum oxide charges there. So I'm going to write my formula. Don't forget on your oxygen gas, on your Cliff Bronze, to make sure you include the subscript there. And now I'm going to balance. So I've got 1 aluminum here and 2 aluminums here. So I'm going to put a 2 in front of the aluminum. And then I've got 3 oxygens here and 2 oxygens here. So the best way to balance that, the most common denominator, is you're going to get each of those to equal 6. So if I put a 3 right there, that means I need to put a 2 right there. So then I'm going to check one more time to make sure everybody's happy. So I've got 2 aluminums here. But now that I've added that coefficient, that 2 aluminum is multiplied by that, so I now have 4 aluminums. So I need to go back and change the coefficient in front of that aluminum to equal 4. So you might have to go back and change coefficients every once in a while. So now 4 aluminums, 6 oxygens, 6 oxygens. So that looks balanced and everything's good to go. Alright, so on 11 and 12, or excuse me, 12 and 13, we've got some rules for you. So the balancing order is you want to balance carbons first, and then hydrogens, and then oxygens. So these are what we call combustion reactions, and we're going to get into these much further towards the end of this unit, and actually a lot in second semester. So you're never going to need to know these hydrocarbons here, which are carbons and hydrogens in a compound, so that's why we give them to you. And then the last thing that I want you to do is write down the acid names. And so we've got acid names, helpful acid names, so hydrochloric acid, hydrobromic acid, hydrofluoric, hydrosulfuric, and hydroiodic acid. Those are your binary acids. And then your polyatomic acids are nitric acid, sulfuric acid, phosphoric acid, and then carbonic acid. So write those down, add these to your periodic table, and you can use those as a reference because you don't need to have the acid names memorized yet. Alright, so thank you for coming ready to class. We will practice the rest of the front and back side of this sheet in class together. Thanks.